I wanted to remind everyone that we are doing our monthly membership meeting a little bit off cadence. This month, it's actually the 5th Wednesday and Thursday of the month. One for North America and Europe, it's 1 p.m. Eastern. On Thursday, we will have Bill Corbin presenting about some work zone safety applications on the 33 Smart Mobility Corridor, some projects they're working on, and that's, of course, in recognition of the National Work Zone Safety Awareness Week. So please do join us Thursday at 1 p.m. if you have time. Also, our early bird special for Plugfest registration did expire on Friday, but we are still taking registrations. We are quickly running out of test station space. We do have more limited space because of the COVID regulations. But right now for test stations, we have Danlaw, Keysight, Nordsys, SEA, Roediger & Schwartz, Waitse's, and WSP operating test stations. And we are, in addition to 3 security certificate providers, BlackBerry, Integrity, and Microsec, and we are starting to get a good number of devices registering for Plugfest. So if you do have C-V2x devices for testing, certainly encourage you to register. I'll ask either Ryan or Kate to put the registration information in the chat box. And with that, I'm going to ask Randy Roebuck to introduce our guest speakers.
Hello, thank you for everybody coming. This is a very important component of the V2x system. It basically is a message generator that could be used by a lot of the IOOs out there in connect and intersection deployment. And this program has been sponsored by Deb Curtis at Saxon Labs under the open source software. And I've actually had the opportunity to present a few times here in the last year on the open source software, the V2x, and the tools and that stuff. In this V2x Hub has quite a few components to it. They are in the process of implementing this V2x Hub, where it has both positive and negative profile testing cases, that this tool can be implemented either on a Linux laptop or a Nano Raspberry Pi type device. Our suggestion is it's probably better on a Nano Pi if you're running a Windows-based software, because it does get a little complicated and that stuff. And this is a perfect peripheral to put with the other test tool systems in a test laboratory. The Nano Pi type very reasonably inexpensive device to put the software on. It should cost somewhere in probably the $200 to $300 range with all the accessories on it. So it makes it a very convenient platform to do it. They're also planning to present the updated status on Cave in the Box, which is kind of a unique tool out there that they're having educational institutions and other things to get a flavor of V2x technology, where it does combine the V2x Hub, a traffic signal controller, an RSU, and software, so they can actually bring the box and implement, test, and that stuff. Currently is in a DSRC mode only, and they are converting it to LDX. If we would have had our Austin Plugfest, Saxon Labs was going to loan a tool to come there and test with. However, we weren't able to hold so-called the in-person last fall, and actually Saxon Labs and Animesh actually got to test their first LTE RSU when we were in Detroit in the fall. So, so they're in the process of doing a next release probably within the month, and I believe that's also going to have so-called certification verification elements, or at least the starting of them, that Aaron and I have been working with them here for a while. So I'd like to hand it off to the Saxon Labs team who's on the phone. Hopefully you have your hardware so you can actually step through and load the open source software and actually have your V2x Hub working when you get off of this meeting. I know both Aaron and I have our V2x Hubs open and ready to see what the new things coming out and get a little more educated with all its capabilities. Animesh, you will be the one that will be presenting, or is someone else from the Saxon Labs team?
Hi, Randy. This is Animesh. Can you hear me?
I can hear you.
Perfect. So I'll be presenting, and there's going to be a couple of us talking about this project, about V2x Hub, Cave in a Box, and how we intend to go forward. We also have a couple of demonstrations for you guys so that we can show you how the V2x Hub middleware can be brought up, and how you can work through the GUI and any other troubleshooting, quick troubleshooting that may be required. Of course, there's always a CV support services that's available at your disposal. We will be pasting the link in the chat pretty soon. You can always get in touch with us if you have any more questions about it. Before we get into the actual V2x Hub and the presentation about it, I'd like to ask Jitong Wong, who's also on this call, to help us with, or rather to provide some overview of the project that led to the development of this specific use case for V2x Hub. Jitong?
Yes, thank you, Animesh. Thank you, Randy. Good afternoon or good morning, everyone.
I believe Mustafa is trying to talk in the background. Mustafa, you have a question? Okay, just background. Go ahead.
Sure. Yeah, just yeah, we are glad to provide our updates for the V2x Hub development for you. So this work actually under FHWA project, which is designed to develop several test plans to support OmniAir or other testing agency to do testing for the RSU and the OBUs to make sure their functionality meets your needs. So we developed 5 test plans under this project. 2 test plans for SPaT. One is against NTCLP 12.2 version 3, and another one is against SAE J27 certified. And we also developed test plans for MAP, PSM, and the team. In order to help the agency to streamline the testing and verification process, we just developed a plugin of the V2x Hub to reduce the manual process to implement the test plan. So that's a major purpose of this presentation. From here, I will turn over the presentation to my colleague, Animesh.
Thank you, Jitong. As Jitong introduced, we'll jump straight into V2x Hub without wasting a lot of time. I do understand that some of you on this call may not be familiar with V2x Hub and the concept of this middleware. So we'll start by introducing V2x Hub, and we will then move on to other elements, like Randy mentioned, the Cave in a Box, as well as the V2x Hub tool that will potentially provide stakeholders with the ability to test or run through the test procedures for the RSE test plans project that Jitong mentioned earlier. So moving on, we have Anjan Rayamaji. Anjan, if you can talk a little more about V2x Hub and all that it has to offer. Thank you.
Hello, good afternoon, everyone. This is Anjan Rayamaji. I'll be talking here today about V2x Hub, kind of providing some description about what actually came up with this software. And we have a couple of demo in the process, and Animesh will discuss some of the other aspects of this presentation today. V2x Hub is basically an open source software that's targeted for allowing different use cases to run in synergistic with different kinds of technology that allows connected and automated vehicle to work. So you have different applications that you need to support. You have different technologies that you need to support, and different message types, different kinds of standards you need to support. So we wanted to create a system that would allow an application developer or a tester or a researcher be able to use different aspects of this system and be able to say, okay, I want to run this kind of application. What would I do, and how would I understand this kind of message, and how would I translate this kind of message, and how would I move that message through different aspects of a certain application? So different aspects of applications, for example, pedestrians, infrastructure, vehicles, cloud applications. So we wanted to create this synergy system that would allow you to just talk with it, send messages to it, be able to incorporate that system into your application, and basically support different kinds of current and automated vehicle applications in general. So it just to highlight some of those points there, it provides a platform for CAVs, deployers, and develop custom software solutions. So you could use this open source software, develop your application, run on top of it, and deploy that on different standard, different devices, different kinds of scenarios. Reduce labor costs and redundancy, so it's already there, so you don't have to do a lot of core application standard, message standard translations that we already have done for you. And it basically allows new technologies to be involved. So for example, this existing V2x Hub system, this application, or we call it middleware, because it kind of sits in the middle of the whole application chain. So you can use that for running tests on CV2x devices if you would. So it's very network agnostic. So you would be able to run applications without caring much about, okay, who's handling the networking, who's handling the messaging, and who's handling the distribution of messages, that kind of that side of the infrastructure that much. So you could just focus mostly on the data. So yeah, anyways, next slide, please. So just a brief, I don't want to spend much time on a couple of slides here, but basically an ITS system consists of, it's a very complex system. You have different standards, different protocols, different vendors, different ways of solving, different ways of creating these devices. So we wanted to say, hey, you have this complex system, you want different parts of this complex system to talk with each other, and we wanted that communication to be standardized, to be something simple, so that an application developer doesn't have to worry about, okay, how somebody's talking with somebody else. So that's where this middleware concept kind of came in. So we would plug in our middleware into this application chain, allow it to talk with like the network side, talk with the application side, and do the translation of different data and different messages in between. So that's pretty much what V2x Hub came in to be. Next slide, please. So that image over there is a V2x Hub we run in our lab. It's a small Raspberry Pi. It's actually a NanoPi, a small form factor, doesn't require a lot of processing power. And you could just deploy this using in a wired network or in a wireless network. You can deploy it in any way you want. So that's pretty much what a V2x Hub system looks like. And this set of slide here kind of discusses, okay, what different components of this complex system are. Okay, a simple connected automated vehicle system, but it's just a simple way of saying it. But you can have different kinds of different protocols running at the same time. So, for example, there could be like emergency vehicles. There could be emergency vehicles with different requirements. Pedestrians. There could be like weather sensors and weather network infrastructure. And then you have the vehicles and a lot of vehicles. And you have this infrastructure on the roadside. So all of these chained up together, we wanted to create a system that would talk with each one of them. And then as an application deployer, for example, if you're deploying a pedestrian safety application, you wouldn't have to worry about, okay, well, how pedestrians are actually, sending data to this application. So that's the part V2x Hub would be able to handle for you. And this goes out to talking with different specific devices, like for example RSUs or signal controllers, vehicle side, even the messaging system on the roadside, like work zones, for example. So all these things V2x Hub is capable of communicating with, following a certain standard. So just a slide describing, okay, why do you think V2x Hub is necessary? Is because it's a centralized hub. It's a centralized hub for a distributed system. That kind of answers the main question. It allows exchange of different kinds of messages, translations between vehicles and pedestrians. And the important thing is it allows easy deployment and development of applications and testing of applications. It allows for you to look at, okay, what messages are coming in and how they're coming in, and okay, what frequency they're coming in. So you could look at, okay, how the application is performing and how many warnings you're getting, and all those things tied up together. So a couple of features of V2x Hub, they're basically standard. They follow the standard 2735 anti-CIP. They allow you to remotely access devices. So using V2x Hub, if you have a V2x Hub system deployed on a roadside somewhere, you would be able to remotely access it, be able to look at different applications running on it, and different applications supporting it, and different messages coming in. It allows easy development and deployment of new CABs. It allows you to connect infrastructure at very low cost. It does support low latency and high reliability communication. So we want to make sure that the V2x Hub is not the one that's the bottleneck. So we developed it in such a way. It supports certain standards. For example, as I said earlier, like 2735 and anti-CIP, and even 802.11p for the networking side. So yeah, now that's this basic description of V2x Hub. If we want to go into a little bit detail into it, it actually has two major components on it. One is the core, and the other one is the plugins. The core, as usual, core is it basically handles all the internal nitty-gritty stuff that goes in there. So message circulation, message translation, so security stuff. Overall, it handles how V2x Hub operates. And core is, we developed core such that it pretty much looks like you're talking with the core. So if you have an application, you would talk with the core, ask it to translate a message, and it responds back with the actual translation and things like that. Or circulate a message, it will circulate a message out to other applications to receive. So it does those things. And on the other side of the core exists the plugin. The plugins are the front face of V2x Hub. So you would run your application as a plugin. So for example, there's a plugin for pedestrian, there's a plugin for work zones, there's a plugin for team message, there's a plugin for a SPaT, a BSMs, things like that. So each message type would be supported by a plugin. Each application view would be supported by a plugin. So you would use plugins to deploy different applications at your site, at your infrastructure, at your research lab, wherever you want it. So this slide here kind of discusses, okay, how things are tied up together. So you have message translation, message circulation. So these things are built up in C++, so they're inner core, and then you have the outer core, which is which is basically the plugins. So plugins talk to the inner core, and basically inner core does the translation and circulation. And right now we have everything in the main V2x Hub system is developed using C++. We are developing some part of it that are not in C++, like Python and Visual C#. But those are actually tools that make V2x Hub better. So the actual inner core and the plugins are still developed in C++ systems. So this slide here kind of showcases all different types of plugins that we have at the moment. With a very near release, I believe this slide is going to be updated. We have a few more plugins to add. But basically, you can see that the inner core is surrounded by different plugins that talk with it, and then also the plugins are the one that talk with the external interface and external devices. For example, there's a plugin that all its job is to basically send messages out to RSU for forwarding out, for broadcasting using DSRC or CVTX. And there's a plugin for receiving anything that comes from that RSU. And there's a plugin for pedestrian safety. There's a plugin for basically SPaT message. So that SPaT message plugin kind of interacts with the signal controller. and it converts right now it converts A2 to I think it's NDCI bit version 2. It converts that over to the standard SPaT 2735, and sends that SPaT to the other plugin that handles sending that message out to RSU. So see that chain. So it's kind of how that works. Yeah, so these are the different plugins. With that, just a quick rundown of V2x Hub. I believe OmniAir is next with a demo and some more information about Cave in the Box. So if you have any questions, yeah, go ahead. If you have any questions, please do have them out.
Thank you so much, Anjan. So that was an overview of V2x Hub. What we will do is we will now delve into the platform itself. We will open up the middleware, run through the GUI, and try to show you the different pieces and what you can do with it. And once that is done, we can then move forward and talk more about the other applications of V2x Hub. Now, if you are familiar with Docker, one of the first things that we did with V2x Hub was we Dockerized it, so it now runs in a container. It has 3 different pieces that are required for V2x Hub to be executed. The first piece being the actual V2x Hub image itself. The second piece being Apache PHP that gives you your GUI elements, and the third piece being the MySQL database. So all these 3 together enable V2x Hub to function with its full functionality. That's something that we've been able to separate using the Dockerized and containerized environments. Knowing this, we have right now I have my V2x Hub instance brought up. There is a pretty simple command. We have an initialization script inside the V2x Hub source repo. We will also, towards the end of this demonstration, I will run through the GitHub source repository for V2x Hub to show you where all of the important pieces are and how you could potentially set up your own instance of V2x Hub. As Anjan mentioned, I will run through some of the plugins, at least some of the important ones for now in the interest of time. You can please feel free to ask any questions that you may have regarding any specific plugins that you want me to cover in the chat, and I can kind of improvise and try to get you the information that you're looking for.
Is this for people who need some time to load this and that type of stuff? Kate, are we recording this so people can actually run back through this to step by step? So the purpose of this meeting was not to have to call the Saxon team order to get it loaded and that stuff, and hopefully they provide enough information we can get people can get things running on their own.
Randy, I'm hoping that we can record this meeting if we are, and if we are not, we do have a recorded session that is going to be made available through USGOT channels that we can share links with the OmniAir group for. So even if we're not recording this meeting at this point, I would rather have I'd rather run through the entire system and how it's done, and of course we can share any other recordings that we may have. So.
Now, Kate mentioned this is being recorded, so they'll at least have 2 different sources. Thank you.
Awesome. Thank you so much. So one of the first steps that you would do is in the chat, I've mentioned a GitHub repo that is available. So you may be able to download V2x Hub using a simple git clone command and try to download the source code for V2x Hub. The source code being available also gets you the ability to potentially create your own plugins, and then of course we can provide you with support and enable you to run your specific use cases. Knowing that, we can show you how we can quickly get V2x Hub downloaded from GitHub. It is as simple as that. Once you download the source code, you have all the elements necessary to potentially spin up your own instance of V2x Hub. In the interest of time, I will not go through the entire process because it does take a significant amount of downloading. So you will require a stable internet connection to be able to download the V2x Hub images that are pre-configured for you once you're done with this step. At this point, we have once this specific instance of V2x Hub is downloaded, then all you have to do is go into the folder, and we have some preset images created. Depending on your system, it could either be an AMD-based processor or an ARM-based processor. One requirement of Docker is that you need to have a 64-bit processor for any kind of containerization to work. Once you have that established, then you could potentially just use the image that is specific to your processor and spin it up. In both cases, we do have, in this case, since this is an AMD-based system, I'm going to go into the AMD-based system. You have an Initialization Sh Script. This script enables you to set up your initial password or login credentials for your instance of V2x Hub that's going to be specific to you, and it'll also download all of the other information that is necessary for you to spin up the instance of V2x Hub. As you can see in the chat, Anjan also put in the link to the specific file that has the Docker instructions for you to simply pull up your own instance of V2x Hub. Once the instance is up, all you have to check whether V2x Hub is running is to use the same command that I have used up here, which is sudo docker ps. That gets you all of the 3 containers that are up. And once you confirm that they're up, then you can start accessing V2x Hub. It is as simple as that. You have to be able to access V2x Hub, you do need access to a browser, and that browser will essentially resolve to your local host where V2x Hub will be loaded, the GUI element for V2x Hub that lets you access and control and modify the various plugins. So at this point, I will log into my instance of V2x Hub to show you all of the plugins that are available and all the plugins that you could potentially use. I won't go through all of them. I'll probably just skim through some just in the interest of time. And then if you have any specific questions, please feel free to stop me or put your question in the chat, and then I'll try to address those questions as quickly as possible. So moving forward, some of the important plugins that we have used that are more critical to our the RSC test plans, those would be, first is the SPaT plugin, the signal phase and timing plugin. This plugin has configuration elements that lets you receive in this case the PSCBM message, the traffic signal controller broadcast message that was set up through the intermediary version of NTCP/IP1202 version 2 and 3. And that message is then converted to an SAE 2735 SPaT message. We are currently looking into potentially adding future support for NTCP/IP1202 version 3 as and when that standard has been implemented on controllers that we can start testing with. So this essentially gets you the signal phase and timing message that will then be sent to an RSU, which will use the immediate forward functionality of that RSU to broadcast that message out. The other message or the other plugin that is critical is the map message plugin. In this case, the map file itself is created using the USDOT map creation tool, the ISD message creation tool, that will then have have the UPR encoded map message loaded onto V2x Hub using the path that is available already preset in V2x Hub. And based on the instructions, you can potentially pull up a map, any new map that links with your SPaT message to be sent to the RSU using immediate forward. So these are a couple of the plugins that have direct relation with the test plans that we have created and that are available as of now. There are 2 future test plans that are currently in the works and should be released once they are once they've run through USDOT Public Affairs. One of them is the TIM, the Traveler Information Message test plan that potentially enables testing of any TIMs that are being implemented at work zones or for speed restrictions or other such use cases. So we do have a TIM message plugin to provide a use case for this traveler information message. that lets you set up parameters, including the broadcast parameters for date and time, as well as it also enables you to do two things, or broadcast in two ways. One is you can create a file using the USDOT tool and load it up in a known location on the V2x Hub computer, or you can have a web service IP set up, and there is an XML format that we have available on GitHub as well that you could potentially use and send these traveler information messages for broadcast to V2x Hub from a remote source. So for example, a TMC could potentially be sending an XML for a TIM message to a remote V2x Hub at a work zone, and then V2x Hub could potentially create the SAE-J2735 message out of it and broadcast it out. So this is the TIM message. The other plugin being the pedestrian plugin, where we have a test plan created for PSMs. PSMs in this case also use an XML-based system where there is a web service IP, and potentially a nomadic device or a pedestrian sensor could be sending messages, XML messages to V2x Hub with the parameters mentioned in it to then be converted to an SAE-J2735 PSM message that can be sent out using the RSU as the radio. So these are a few of the plugins that I think are critical at this point for the creation and sending of messages. Our test plans are kind of centered around systems like these that can then use the RSE, or rather the RSU 4.1 specification and any future updates to be able to give a proof of concept, a demonstration of all these systems, as well as then help build test plans around the specific applications. So those are some of the applications that we have. Some other applications that we can potentially discuss, or I can just quickly run through, is the curve speed warning application, which is very similar to the traveler information messages. However, in this case, it also creates a map of safe speed zones, and it can be divided into 4 segments with increasing magnitude of warnings for the drivers. So we have a demonstration for that as well. So this V2x Hub device can be used. Source code for this application is available on GitHub that may then be used for any other systems or use cases that are as you guys see fit. Then the dynamic message sign uses the NTCP 1218, I believe, for sending out a message to a DMS sign. This also works in conjunction with this curve speed warning plugin, where a message or the vehicle speed being recognized from the BSMs can then be translated to a message on a dynamic message sign to warn the driver about excessive speeding or being within the safe speed for that specific curve. The DSRC message manager actually acts as both the DSRC message manager and the V2x message manager because of the use of the RSU 4.1 spec. It enables us to use the RSU as the radio for which makes V2x Hub essentially technology agnostic or wireless technology agnostic, and enables us to use the immediate forward functionality as enabled by the spec. Message receiver plugin is another interesting plugin that actually uses the opposite of immediate forward, and in this case it uses the WSMP forward piece and receives for V2x Hub to receive these messages and potentially use them for various applications. So this is how V2x Hub will receive BSMs from an RSU that will then enable the curve speed warning plugin as well as the dynamic message sign plugin to relay real-time information or real-time warnings to the driver as and when required. ODE is another plugin that enables V2x Hub to communicate with the operational data environment set up by the USDOT or the proof of concept that is currently been set up by the USDOT. And of course, there's more opportunities for development here. This is another plugin where we are continuing to develop in our current development cycle, and we will be adding more functionality to this plugin future releases of V2x Hub, we'll see a couple more plugins that that will enable us to potentially use the operational data environment even better. There are more plugins like the RTCM plugin, as well as the message logger and the SPaT logger and the BSM logger plugin. All these three plugins enable logging of messages and storing them either in files as binary files, or also potentially streaming it out as a Kafka stream for any remote subscribers that might require messages within that same network. And then finally, there is the Preemption plugin. The Preemption plugin is a proof of concept for enabling an emergency vehicle preemption. It uses, in this case, it uses BSMs and the license sirens flag in BSM part 2 to identify the position of the vehicle and the status of the vehicle, and accordingly send a warning, or rather configure the controller, call a preemption table on the controller to enable a green channel for an emergency vehicle. There are, of course, updates being made to this plugin, or would be made to this plugin as and when the standard develops, and there is technology available for us to potentially use the other features, including the SRMs, the signal request message, and other such messages that are currently being developed. I see that there is a question from Randy about the SPaT map components that are being updated from the connected intersections mandatory elements. And Randy, the answer to that is that our SPaT plugin already did include some of the mandatory elements. We do see that there are some more fields that may be added to the SPaT messages, and we are looking into that, looking into the developments of the connected intersections project, and kind of improvising and pivoting accordingly is in our strategy to as we develop and move forward in our development cycle this time around. So some of those elements will be added as well. In this case, also, I think I do see a question from Sean about the 1609.2 or .3 wave headers. I believe those headers are added further by the RSU. The V2x Hub at this point also does not do security certificates. The certificates are also being added at the RSU level, which is something that the immediate forward functionality provides, and that is something that we will continue to leverage. Thank you. So this is the overall, these are the various plugins that are available with V2x Hub at this point, and I'm sure there are more that are going to be added, as Anjan kind of mentioned early on. Our current development cycle will add more support for ODE, as well as add some security features to V2x Hub, and potentially update the standards, or provide updated plugins based on any new standards or changes to the standards that have happened. In this case, so a question from Pradeep is whether the SPaT plugin supports the NTCIP broadcast message. That is correct. The SPaT plugin does support the TSCBM, which is a UDP-based message, and it is a constant message 10 times a second that is being sent to V2x Hub, and that is the only SPaT support that V2x Hub currently offers. We are yet to investigate the NTCIP Turbo 2 version 3, which is slightly more complex as compared to the UDP broadcast. So as and when more devices are made available, we will or more controllers that we can work with and research to understand how the NTCIP Turbo 2 version 3 would affect or impact us. We will move towards that. I do have another message from Tom Timchell. So in this case, the messages still are probably signed, and the signature is being recorded or identified at the radio level as soon as the message enters the radio at the RSU and the OBU level. Tom, if you'd like to unmute and have a kind of articulate that in a way where I can potentially provide you with answers, maybe that'll help.
Just what what we ran into with a lot of the deployment is that everything is being signed, all the certificate handling is being done at the RSU level, but I'm not sure that that's really going to satisfy the long-term needs of the OEM community in terms of authentication, as well as with the IOOs, if we aren't able to maintain those certificates further back in the system both ways.
Right.
So that's all.
That is actually a really good point, because we have that is something that we have considered, and as we further enhance security for V2x Hub, that is something that a very similar strategy is what we intend to implement, is to be able to sign the messages further up, and that is also true because V2x Hub ideally would be sitting in a traffic signal controller cabinet with an Ethernet connection back to the RSU, where there could be potential security concerns that we might want to mitigate. So as you said, I think that is a strategy that we are mindful of and would consider implementing if we have the resources. Thank you.
Yeah. On the inbound side too, you may want to consider as more and more the use of the SSP along with the PSID to authenticate the type of certificate that's coming in there. Unless identity certificates are adopted, you know, the use of the SSP to maybe identify what type of vehicle that's being transmitting the request, because what's in the SPaT message, or not a SPaT message, but in the signal request message, it can say whatever vehicle type it wants to be, whether it's a fire or police or transit, but it's only through the certificates can you truly authenticate if it is indeed a fire, police versus a you know, a transit or something, and that would change whether you're asking for preempt or priority.
Absolutely, I think that makes perfect sense, and yes, that is something that we are considering, and we're also looking at potential hardware that can support HSM, or that could potentially have an HSM that enables just that. So, so stay tuned for updates. We will, as we continue to further develop this project, we will try to add those features and keep you updated on the same. Thank you so much.
Yeah, no problem.
And,
I don't know if Deb's on, but just it's nice to see my old friend there coming along so well. So thanks.
Yes, I know. I did realize as soon as you started talking, I did realize that I think we've spoken before about this, about V2x Hub in general.
Yeah,
I don't think Deb was able to join today, but I will convey to her that you have some recommendations, and I'm sure she'll be open to it. So thank you. And so just a couple more pieces of V2x Hub. Of course, you can look at the messages, all the messages that are coming in, going out, and any updates that are happening will be shown here. Right now, I have this running on my local system, so I do not have it connected to the intersection. But this is essentially just network configuration that will enable you to send and receive messages. You also have an event log that tells you enough information about what's happening. You can further change the debug levels to understand if you intend to develop any kind of plugins or applications, you can further use the event log and try to troubleshoot it, as well as you can create more users depending on your specific use cases. So this is V2x Hub as a whole. Of course, there's more to it certainly that we can talk about as we go, as we get more questions, or as we continue to take our conversation in a direction that benefits this group. So at this point, I would like to stop this demo, get back to the presentation, and continue with the cave-in-a-box part, which is kind of a one use case of V2x Hub that we have seen in the immediate need, and then we'll certainly also talk about potentially tailoring this for a specific use case like a test facility.
Hello, Animesh. Thank you very much for the V2X. You might want to go of what you're under development to help this for certification and basically.
Right. So that's where we're getting to
out
right now,
and
Randy.
verify back, and whether you have so-called negative and positive profiles you can attach, so you can run a standard set of positive and negative parameters through all these things.
Right. So Anjan has that demonstration ready for you, and we'll be getting there in a few minutes.
Okay, thank you
All right.
very much.
Thank you so much. All right. So quick use case for V2x Hub. What we did identify was that was the education community needed a system that kind of encompassed all of the pieces of an ITS equipment, and that we wanted to ensure would be a part of easy deployment and easy research. So that is why we came up with this concept of cave in a box. The reason we're mentioning it here on this call is because once we had it developed, we did realize that beyond academia, it did have more users, especially when it comes to a test, essentially a testing laboratory that could make good use of a system like that. So I'll quickly run through what it is and how we can go about using it, and then we'll jump into the demonstration that Anjan has for us for the test plans. So in this, it is created for educational use. Originally, it has most of the features of an ITS infrastructure. So it's essentially an entire intersection, a smart intersection packaged into one portable box that you can potentially use. The idea behind this was to be able to educate the technical workforce and provide enough hands-on experience. And then, of course, now that we've seen how labs operate, I think it does have value there as well. So moving to cave in a box, it has all of these components. As you can see, it has the V2x Hub, a traffic signal controller, a roadside unit, and all of what goes into an intersection, along with any backhaul connections that may be necessary. We have two kits primarily. The first one is the Rfu Kit. That is essentially the intersection side, or the infrastructure side of things, where we have all these different components, including a tablet or computer, to be able to configure all of the other pieces of the infrastructure kit. It essentially should be used in a laboratory. It's not for deployment on the streets, but it provides with a really good use case for lab-based demo. And again, also could be a really good test tool. And then we also have designed a couple onboard kits, or the Obu Kits, which will have all of the pieces that are necessary to be able to set up an Obu in a vehicle and try to enable interaction with the Obu. Of course, all of this is portable, is concise, is in one box. It's also going to be available through the equipment loan program once we have finished with our initial user group demonstrations. And then as we go about it, this is the overall infrastructure in which cave in a box fits. You have your the infrastructure piece here, you have your vehicular piece here, and then you can always send messages using nomadic devices, as well as potentially set up backhauls to your TMC. So this is where the two cave in a box units would fit, and that is an excellent use case for anybody that is intending to test their own systems in the context of other devices around that infrastructure. So with that, now we are quickly moving over. We just do a quick couple slides on the test plans. I think Jitan kind of touched on this earlier. We do have the test plans that we're primarily supporting, and this will be a good segue into what Anjan wants to show. We will potentially be showing an example of the map SAE test plan, one example of the map test plan that, as Randy said, would potentially show all the other values and how that impacts. These three test plans essentially get into the details of the standards and try to test each and every field, especially the mandatory ones, against the values that need to be available or need to be applicable to those specific fields. If the values are bad, then the device fails, or the application in this case fails the test plan, and then it will have to be correct. This is very critical when it comes to being able to send SPaT and map messages out in the field where things or vehicles are potentially going to be in safety critical situations and would require correct messages to be sent in order to make the right decisions. so as you can see, there is we have a generic test environment here that we have set up with the traffic signal controller, V2x Hub in the middle. You have a roadside unit. The packet sniffer essentially is a software tool at this point where it reroutes the message back to this packet sniffer or for V2x Hub to analyze, or the tool that comes with V2x Hub to analyze and provide the test lab with the results. Just to give you a quick example of a test case. So this is how a single test case would look. In this case, we've picked an NTCIP-1202 version 3 test case where it looks for a specific status of the light based off of the various options that are available. And as the test lab is able to set up the traffic signal controller for the outputs to a computer, they're able to receive all these outputs when the output is within or outside of this range. Say, for example, in this case, it has to be between 1 and 5. Then it will fail the test. Or if it is, say, for example, in this case, protected signal, then that is being shown on the actual LED display. Then it is also important for the SPaT message to kind of translate the same and within the acceptable time frame of the set by NTCIP-1202 V3 standards. So all these things are being considered in the test plan, and there's each of these 3 test plans, the NTCIP-1202 version 3, the SAJ2735 SPaT, and the SAJ2735 MAP look at the standards and are only specific to the standards that are defined and that the devices or the applications should be adhering to. So I'll just quickly run through the steps where the test lab would potentially be using the NTCIP-1202 data and sending that UDP packet. In this case, again, this test plan has been centered around the UDP-based stream that is kind of used for V2x Hub, as well as was available through the NTCIP-1202 TSCBM. It will send the timestamp packets to a computer and will be converted to Uber using J2735 messages. A particular state of phase will then be identified for testing. There will be information including the min end time as well as the max end time, and all of those information will be verified based off of the specific fields in the SAE-J2735 messages. And then that will then be compared to the NTCIP-1202 message that was originally sent from the controller to ensure that it has conformity with the standard, as well as it continues to be translated in a similar, as in the values continue to be translated correctly. And this is just one test case, and this test case kind of covers that specific piece in this case for the device or the application. So this was just a quick overview of just one example test case. We have all the 3 test plans available. I believe I think they have been shared and they've been published and are available online as well through Rfu. But I think if anybody has needs those test plans, you can certainly get in touch with the support services at DOT.gov, and we can try to provide you with more information. With that, I will stop presenting, and if we can give Anjan the opportunity to present, he should be able to provide us with the quick demo for the actual test tool that he's developed that works with V2x Hub. Thank you.
Thank you, Animesh. Okay. Do you all see my screen?
Yes, I can.
Okay. All right. Okay. So all right. So we already have this tool kind of put up in GitHub for anyone to use. It's an open source software. If you go to V2x Hub GitHub webpage right now and go into the tools folder, there should be a validation tool, and it's a Python software that we developed specifically for testing the RC test plans. So the way we laid this out is basically there's this file, we call it a test objective file, and this file is more of a generic file. So you can you can use the same file for testing map message, SPaT message, or even the the NTCP, TCBM type of message as well. So for example, it specifically kind of talks about, okay, what object are we looking for and what kind of test we are conducting on that object. So for example, there's going to be a couple of exist. So exist means we want to check if that particular object or anything related with that message exists in the output that we got or not. You know, like if it exists in the output of that device that we're testing. And the objective is, okay, what we are testing. So similar fashion, I'm going to show you the full version of this file in a bit, but similar fashion, you can test, pretty much use the same structure for testing SPaT or map or any of the other kinds. So that's where the testing actually begins. So we first of all go ahead and kind of create this JSON file containing this information. It's very easy. It's kind of easy to create once you have access to the test plan. So it just follows the same test plan structure and laid it out into the very simplified format here. So after that, once we set it up, like our application looks like this. I'll give a quick demo, but I just wanted to go through like the overview of this application first. So the application looks pretty much like that. So you have the first on the left side here. You have the setup. Basically, we kind of set up, okay, where we want to send this message. So, okay, we have a device connected with the system we are testing with. And okay, what kind of device is it? Where do we want to test it? Like, okay, which part of the folder in that device do we want to copy our message into, so that the device would regulate that message and, you know, create maybe a 2735 upper hex, forward it out, things like that. So all this information about all of these different fields is actually given in this README file in the GitHub. And so this block here is the sniffer code. So this is pretty much generic. So you can pretty much write any sniffing TCP dump based command in there, and this application will load that command in the device and run it there. So we really don't need a separate sniffer for this, and it's generic. So you can actually write your own program for that as well. You don't have to follow this. Like you can just have a separate program running in those devices, sniffing or capturing the message going in and coming in, going out and coming in, and then forward that back to this application, which will then process that for testing. So this left side here is pretty much set up. The middle part here on the left, this one here, it shows the content of the message that we want to test against. So the typical scenario would be, for example, if you're testing map message, we would copy that message to the device and expect that device to kind of, you know, encode that into a 2735 and broadcast it out. And we would capture that broadcast 2420 upper hex and feed it back to the application and compare with what we sent to the device and what was received from the device. So this is what we send to the device. So this is editable, so you could actually go in and change it. And this one here is basically, it highlights, okay, which test we are conducting. This is basically a graphical representation of this file, pretty much. So whatever we put in there comes up here, and eventually when you run it and we capture a packet back, we see a result like this. Okay, so we see each test case, what was being tested, and whether it passed or failed. So exist means whether the message we received back from the device had this message ID field or not. So passed means it was there, failed means it didn't find it there. Similarly, unavailable means, so basically if you look at here, anything that doesn't exist. So there's another version called verify. So verify means, okay, we feed the device message ID 12 and we wanted that back, but we received something else. So that's a false for verify test. So these exist and these two kind of tests are already defined in RC test plan. So I'm basically copying that over here. Similarly, and with that application, this could be a test scenario. We have the computer that we are testing with. This is our testing computer or tester, and we have a JSON file. This is the sample file we send to the device that we are testing against. So this is the device under test, and we load the sniffer code in the device, and we expect it to send back a captured message back to the computer. So every time we run a test, this chain happens. So pretty much, so that's for the map test. For SPaT test, SPaT test is basically our device broadcasting SPaT message. So we only need to capture whatever goes out of it. So we just only send the sniffer code load into the device and basically route that message back to the computer. So with just the brief introduction here, I'm gonna quickly go to my computer here and I'm gonna run that up. Okay, all right. So in this case, I really don't have a device that I'm actually testing in, so I'm gonna run a sample mock test here. So I'm just testing it against on my computer. So I'm just routing it to my own IP address. So in typical scenario, this would be the IP and port of the device you're trying to communicate with. And this would be the SS connection, SS information for the device you want to log in or copy files or do other things with it. So here, and there are like there's two options here. Do you want to load the message or not? So do you want to copy a sample message to the device and compare whatever comes back from the device with the sample message that you have? Or do you not want to do that? I mean, it's either you're doing the map test or SPaT test. So I would copy it there. So where do you want to copy it in the device? So I would give it a, for now, I'm just gonna give it my home address, home location, but you could give that folder location or the path location for where you want that message to go. And and this thing is kind of like a vendor dependent, so it varies where you want to copy it. Now you can, if you want to copy a sample file over, I'm just going to select a sample map message here. So that's, I selected a sample message that I want to copy to the device, and then this is the test setup. So this is where this file comes in. So if I want to show you that file, okay. So this is just, I showed you a sample earlier, but this is just the full version of it. So it just has a structure with different test cases and different basically message values. All right. So and then so what this one doing is it sets up a test, creates that test message object file using the JSON structure, and then we expect. So this port number basically goes back to the location where we want the sniffer code to send the message back to. So it's basically that port number. So whoever is doing the testing can change that wherever they want to get that message back from. So if I do that, that's the middle part where now you can actually go and change that. Like I don't want to change it right now, but you could change this. So you can make changes to this message, however you want to test it. And then when you make a change here, and you can actually unselect, like if you don't want to do some couple of tests, you can unselect those. And once you press run, then it actually copies whatever is the content of this frame and sends to the device. So it becomes live now. You can actually change it here. If I run it here, now I do not have a device running right now, so I'm gonna sample back so I'm gonna just send back a sample upper hex code back. So once it receives the code here, once it receives the message back, it's gonna print out. Okay, it's gonna run the test, compare with the different fields, and then give us a summary of okay, what happened, what passed, what failed, what was available, what was not available, and if anything was verified, not verified, things like that. So yep, so that pretty much completes the testing, and you can immediately run like a SPaT test as well if you want. You can preview that. Creates a different kinds of message format. So this becomes a SPaT message format. This should be this one here, and it should be a sample. Actually, we don't need to send anything here, so I'm just going to take a no. So yeah, this becomes so SPaT has a couple of different new fields we want to test again, so they get added up to the field and you can run the test. So yeah, so that this way you would be running the RSC test plan test cases in series with just this application. Yeah, that's pretty much, and it actually generates a report. I believe so. Yeah, it actually generates a report like this. So it kind of tells you, okay, which field we're missing, which field we're passed. It's a CSV file, just has everything junk, like pretty much everything copied in there. So once we get a view of this field, we can figure out, okay, which field we want to look into. So this summary is more helpful. Yeah, so that's pretty much the tool that we wanted to kind of demonstrate here today. And this comes as a part of V2x Hub. It's not a plugin, so it doesn't work as a plugin like a plugin, but it's more like a tool that uses V2x Hub as a component. So yeah, any questions? Let me see. How do I? Okay. Okay.
Well, hello, this is Randy. As far as your, you said you do a CVS data output. Is this
CSV.
per? Is this
CSV.
per the?
Sorry, go ahead.
Is this per the ASN.1 JSON format? The data will be coming out, or is it pure XML or CVS, CSV?
Oh, so it's basically like a dump of each test conducted and each test laid out into like, okay, who was the transmit, which message was the one that was sent out, which message was the one that was received in a CSV format, just like a plain text format. And it's actually a result of the summary. So it's actually what I would say is a description of more detailed version of the summary result here.
Okay, so what about pure data of the message itself?
So yeah, so that one isn't printed right now, but we can easily add that as a part of the, if that's needed, that can easily be added to this code. You mean Uber hex that comes back? So an Uber that comes back is decoded here, so you want to see the decoded message as well, right?
Yeah, I mean, the question is if people save it as a PCAP, if it was broadcast over the air versus the wired internet UDP forwarding, as you got here, they could capture the PCAPs if it's being also transmitted over the air, you know, whether that data can also be saved as an output as a ASN.1 JSON file.
So I'm trying to understand. So you're trying to save a PCAP into an ASN? Is that the question?
The question is in moving forward and connecting the intersection and doing some SPaT map correlation type stuff that the CSV file or the PCAP doesn't give it the data quite in the same format
Okay.
for analysis.
Yeah, that can be added. So like if you have a PCAP, so instead of having this streamed in through the sniffer code, we can actually have it loaded by like if you already have a PCAP stored as part of the process, we can feed that PCAP into this validation tool as well. That can be added. It doesn't do that right now, but that can be easily added. So we would feed that up, and then we can save it into the JSON format for the actual data that contained in that PCAP capture.
So for the verification and each plugin, I know that Saxon Labs was exploring whether they can do the center part of the spoke of the wheel or whether the verification had to be redone or redeveloped for each plugin. Is this now part of the central core? So any plugin you add in the future, it already has the verification element capability?
So we actually kind of looked into this problem, and it looks like the core is not capable of doing any verification right now. So we might have to add that as a separate part, as like an overlay on the message on the plugin side. So we found out that the verification is like it fails if you send a non-verifiable message to the V2x Hub.
So I see the email in the chat where when you're creating map messages or probably any other messages, it doesn't allow you to generate values out of the parameters and see how the device itself handles it. So it actually gets stopped by the hub itself.
Yep. That's what we've seen as well. So that's a feature we are working into adding to V2x Hub right now. So we've seen that V2x Hub kind of doesn't cooperate well when you send a message that's outside the range, outside the valid range of any of the message values. So Yeah, that needs to be added though. We've looked into that problem. We've seen, okay, what's causing the problem. We're just kind of working on kind of deciding, okay, do we want to add that to the code or do we want to add it to the plugin? So yeah, it's on the pipeline though.
And then there's also a couple of questions in the chat if you haven't.
Okay. Yeah. So Mehdi's question, I guess that's the same question where we talked about right now. It's not. It does drop the message. Actually breaks the plugin if you send it an invalid message. That's true. But the verification that I just talked about is more about like a device verification. So if you have a device that you want to send a map message to and expect it to send it out in the right format, or it does not, if you want to just say get an yes or no answer to that, this application can help. So it doesn't have to be the exact. So should the example message be an exact? So I think that's the whole verification. So we have a sample map message and we feed it to the device, and we expect it to regulate that into a UberHex and broadcast out, or somehow we capture that back to the application and decode it. We expect them to have the same values and same structure. So that's the expectation. But sometimes what happens, they kind of have a different. They might have different values, or they might have different fields. So that's how things fail. So this application kind of checks that, okay, you're supposed to send this format out, but you're not sending it out. So that's a yes or no question, and this application will help figuring that out. Any questions? Sure. Sure. Animesh, I think that's.
Thank you. Thanks, Anjan.
Sure. Let me stop sharing.
I think we have 15 more minutes to go. And I think at this point, we will open the floor for any questions that you guys might have for us. Of course, there's a lot that we discussed today, and all of this information is available through all the resources that we've mentioned in the chat before. Feel free to get in touch with us through the CAV support services at dod.gov or any other forums that we will continue to talk about all of the open source development that we are working on at the Saxon Lab.
Do we have any other questions from the folks? I do know that we've had one test laboratory who have implemented the V2x Hub and actually brought back timely comments back to Saxon's labs. Do we have anybody else online that would like to discuss what they've seen here today or how it applies?
So this is Frank. I guess to follow up on what Tim Show asked about security and finding messages and what have you, when do you think that functionality would be available?
For the security?
Yeah,
at this point, we are.
Sorry, go ahead.
Right. At this point, we're just investigating that, and we're currently in the process of understanding how we could solve that problem. We've identified that as our problem statement for this upcoming development cycle, and that is one of the areas that we do intend to address. We're going to have a release in June that would not have addressed the security pieces, but it would certainly add more information, more plugins to V2x Hub that we will talk about as soon as we have finished testing and ready with more information. Once that is done in June, then we will start implementing the security features, and that should take about maybe 4 to 6 months, I believe, depending on how complicated it gets with regards to the specifications and the standards that are available. So sometime after the June time period.
We're
So,
expecting
okay, so
to
early
release-
2022 then?
Yeah, that is something that I would expect it to be ready by.
Okay.
Okay,
So
and then
when
I
do you
guess a
expect-
similar question, do you have a timeline for implementing SRM, SSM?
So,
The no request message, signal status message.
right. So SRMs are already supported in V2x Hub, but we haven't had any applications that run with it. The message itself is supported primarily because it is part of the FAQ 2735 standard. SSMs also we don't have applications around, so that's something that we will discuss internally if there is a need for it. I think we can certainly pass that information on to Deb Curtis, who of course is leading this project from the government side, and we can see if we can get any of those elements up and running or developed. At the same time, since V2x Hub is open source, we can also, if anybody is interested in developing any element of V2x Hub, we can certainly provide you with all the information that is needed to undertake such a development. But I will make a note about the SSM and SRM and get back to you on that. The message itself is supported, can be parsed. We just don't have any applications around it. Thank you.
Okay, sorry. So you can decode it, but that's about the extent of it. You're not sending a request or a call to the controller or to a controller.
Right.
Yeah.
Okay.
Right. So V2x Hub, yes, can decode it at this point. Correct. That's about it.
All right. Thanks.
Mm-hmm.
So when do we expect the new version of V2x Hub to come out? You mentioned sometime June.
Correct. So our current timeline is that we will have the next release of V2x Hub in June. Of course, that will not be the conclusion of the project. There's going to be more development that happens, but since we are doing an agile development for V2x Hub, we will have a release after a certain number of sprints, which happens to be in June this year. So once we're closer to the release, we will have our release notes available that I believe, Randy, we can share with you, and of course all the source code itself will be available on GitHub. That can certainly help us further provide the relevant information that is needed.
Okay, so that's great. If there's no more questions, thank you for the Cave in a Box and SPaT overview and implementation. Tomorrow, as part of the technical working group, we'll actually have SAE present their sniffer and possibly their bench top equipment, along with Wadey's out of Korea, to present their field test tools this week. Is there any other questions for the Saxon Labs team or us in moving forward in order to have a successful Plugfest? Okay, we had very good attendance here. I saw the attendance in the 55 range, and thank you very much. Thank you, Saxon Labs team.
Thank you.
Yeah,
Thank you,
thanks.
Randy.
Thanks all. Bye.
Okay.
Thank you so much.
Thank you. Take care. Bye-bye.